first of all, good morning. Thank you for joining the session. And as mentioned, unfortunately, Jakob is not able to do the presentation himself. Rob has graciously offered to help me. And just in case, Jakob still has a microphone, but we don't know if he's feeling too bad or not. But
we don't know how long he'll last, do we? So
exactly. First of all, thanks to our sponsors. Without this, we wouldn't be able to stand here and give this awesome presentation. Jakob still made a lot of work for getting this up and ready. So definitely consider sponsoring him, visit him on social medias whatsoever.
And go back one a sec. Don't forget, you can get in touch with him. I'm sure he won't mind me saying that these are all the methods that you can use to get in touch with him. Lots of people will undoubtedly get in touch and ask questions, but you are also able to join that queue. He's amazing at responding to things that are coming through. He's really passionate about these things, and he builds fantastic tools.
Then, who am I? My name's Robert. Most importantly, husband to an awesome wife, and I have 2 great kids. They make it possible for me to be here. Besides that, I'm a trainer and a developer at a Dutch MSP called Wortel. And my co-host.
My name is Rob. That's how you can get in touch with me. Find all the details there. Again, feel free to ask questions, and it is your responsibility to go, oh, you haven't answered this question yet. I totally do not mind that. I get so much stuff coming through. Feel free to do that. Reason I'm happy to be standing up here is because I'm involved in a lot of open source projects. And one of the things we do when we build PowerShell modules is we make use of Pester. So on both sides of, if it is working as we intended, Pester, so DBA tools, DBA checks, many other things that we've built. But also, I always say anything that you can get with PowerShell, then you can test or validate with Pester. So DBA checks we also use to validate a SQL Server estate using Pester to do it. So I've spent a lot of time deep in the weeds of Pester, so I'm hopefully can be of use to you. But mainly, I'm going to be the keyboard person.
I'm sure he's going to be able to do a lot more than that. Well, what are we going to do today? As Rob mentioned, it's a follow-along session. You are not obligated to follow along, but that's the best way to learn and to try and fail and try again. We're going to start doing the basics and slowly start using a little bit more advanced syntax along the way. And that should be able to get you up and running on your local projects. We are not going to do the engine and what's driving it. Jakob has some amazing presentations on previous conferences. Please go check them out on YouTube. And like it says, we're going to do this on a live module.
Yeah, this is not about how Pester works. This is about how to use Pester for yourself. Yep. And of course, we are sponsored by the Pester Enterprise Pro Max version. That was an April Fool's joke, so it's just a good T-shirt that I happen to have. It's the only Pester T-shirt I had with me.
It's good that you have one.
So everybody have VS Code on their laptops who wants to follow along? Yes, yep. Rob. There we go. That's how it works. Good.
So, what do we need to do? We need to clone a repository. It's on the PSConfEU organization on GitHub. And the repo is called 2025 Pester Follow Along. And besides that, we had it in the documentation as well that you need the version 6 alpha of Pester. So in case you do not have that yet, please do install it.
If you don't have an SSH key, use that link. Okay, we give you some time. It's not a big repository because we like our Wi-Fi, but who knows what Justin and Jordan are doing over there. So git clone, path to the repository, HTTPS or SSH, github.com/PSConfEU /2025-Pester-follow-along.git. Hit enter. It's going to ask you. It's going to choose the directory that you're in and create a new folder. And if you haven't got this Pester, then use that install -module. Minimum version 6.0.0-alpha.
And
you need to have the allow pre-release. Because Pester is just a PowerShell module. So Robert, do you want to tell the folk who, there are a few that didn't know what Pester was, what it is for, what it is?
Yes. Basically, Pester is a PowerShell testing framework. It allows you to test your assumptions. You think your code does something, whatever your code is supposed to do, and now this framework allows you to test what you think it does to make sure that, well, you actually get the results you need in whichever scenario. So, in that sense, why we started doing this, or what the setup for the presentation was, normally we'll have like ideal code. It's like A plus B, and then A equals 1 and B equals 2, and it's ideal code. And this time we're using code which you would normally use. So you can see how you can start testing or making sure that your code does what you think it does using real-life examples. Just going to check.
Everybody got their repos? Anybody not got the repo cloned who wants it?
1, 2...
Any hands?
Like 3 hands.
Okay, speak to your neighbors. Remember, we're all friends here. We all know how to do this. Okay.
Yep. Okay. Then...
How can you tell if somebody's a runner?
How do you tell if somebody's a runner? They will tell you if they're a runner. Even if you don't want them to, they'll invite themselves over. Apparently, it's like cyclists or vegans. So, looking at the code you have just downloaded, it is a module for getting running tracks, getting running information. So we'll just go through a little bit of the code to see what it is, what it does. We'll show some functions on that it actually works and that you can actually play around with it. And then we're going to make the tests for it. So
now, you're going to have heard a lot about test-driven development. Yeah? But that's not real life, is it? Real life is, I write some PowerShell to make a thing, and now I want to validate that actually it's doing what it should. Yeah, no, okay. There are some amazing people that sit on the front row who are like, no, I always do TDD, which is cool. But, yeah, and you should. But what we're simulating here is real world example. So what does our module do right now?
Okay. So you see you have some private functions and some public functions. Mainly looking at the public function at first, you have getRandomTrack. It gives you a track to run. You have to provide the length, how many kilometers do you want to run, and it will give you a random track. I'll show you just now. That ideally, that's for me as well.
Okay. Yeah, good.
But the one person who actually started loving to run is Jakob.
I cycle, so
yeah. So I'll show you just now that it actually runs and that you can get data from a live API. And once you get a track, you can send that track to your email so you can import it in your favorite running app and play around with it. If you look at the private functions, you have something like convert to KM. So just in case you don't want the metric system, but the imperial system, it can work with that.
Because then you can run further. Right?
Yeah.
Yeah. If you do it in kilometers, you run a much bigger number than in miles. It's much better.
Okay.
Are you going to show some code?
Yep. So I'm just going to drop out of this. Now, first of all, to actually show that it actually runs and works, there's an API that we have built in that you can also run yourself.
Do not run this in your VS Code.
Yes.
Run this bit in a separate terminal window, please. Otherwise, mayhem happens. It's really hard to get out of, okay?
Also, if you want to close the API, you need to actually terminate the process, but I'll show you just now. So if you just open the directory, so I go see cloned.
This directory is going to be wherever you have cloned the repository that you pulled down.
So, that's not.
Oh, that looks good.
Okay, I'm just going to show you the command to run. So it's going to be API start server. And then it's going to listen for you. And in your VS Code, we can then do, this don't. Okay. Come on. Why is my terminal not opening?
Control single quote. Control single quote.
Yeah, it's not doing that. Could you just check this out for me, Rob? Because we're switching machines a bit. We're now using... Oh, that's that's different keyboard.
That's okay.
Okay. So if we import module and I do runner.psm1, I can actually show that it gets data. Get random track. I'm just gonna save it quickly, and I'll show you in a minute why. Yep, sorry.
I got a great big mouse cursor.
Oh, it is running.
I didn't click. I just moved it.
Yeah, I did click. It's not doing anything. There we go. Sorry. Okay. So if you look at the data, I get an actual track, a random track. And the reason why I saved it is if I now do send track and I do it.
Okay, so
My file gets sent.
We've imported the module. Itmo runner.psm1. We've then run get random track. We've got some results out. We've then run send track and emailed Jakob the track choice. So everybody got that going. Everybody getting a result from the API. I'm seeing nodding heads. We're good.
This is what you would normally do when you ever create your own module. You just load it, test it. Everything looks fine. Now, if you actually look at... did we have it open? No.
I think I closed it to be helpful.
Yeah. Okay. So just to test that we have an API running, on localhost port 5000, we have a ratings and a tracks end route. You can see that we actually have data in there. And similar for tracks. The reason why we have two endpoints is one is the track and the other one is how well they're rated by users, just as an example. But you should be able to get this data live on your machine as well.
And even though we're going to do this testing on these two routes for this API, you will work with all of the APIs. Yeah, M365 or any of these things. So this is just a simple example to get you used to being able to test the code that you write against an API so that you can take it back and do it better when you get back to work. That's the idea.
Yeah, because like we said beforehand, most of the examples that normally are given are ideal situations. But mostly in code nowadays, people end up talking to APIs. So we wanted to give that as a real-life example. So this is basically the functions we have and what the code is supposed to do. It's not perfect, but this is what we want.
These are the notes so that I know what's coming up next.
Okay, and this is basically all the slide work we're going to do.
Close PowerPoint. Yes.
Yes. Yeah, I'll save it. Okay, and we're going back to... Yep. Got it.
Okay.
And now that we have... Let me just go in there.
Those are his notes, so he knows what he's doing.
Okay, so first thing up. I think it would be easy to just start doing tests, like the simplest functions. So just the private.
Where do you think, what should we test first? Are we going to test public functions or private functions? What do you think?
Anyone?
Private. Yeah, private. Makes sense, right? Because they're just the simple little ones. They're only going to be affected by that. Yeah.
They have tiny things. It's easy to test.
Easy to test.
It's almost like the examples.
Yeah, makes sense. That's what we'll do.
So we have a function, as mentioned, convert to KM. So if somebody inputs miles, we get the KM size because our API expects KM input. This is a function. You can all open it. That should be doable. Now, Rob.
Perfect. Yeah.
If I want to make a test, how do I start? How can I make a Pester test?
First thing that we need for a Pester test is a file to put our test into.
Where do I put it? What do I call it?
Oh, so where do you put it? It depends. For right now, let's put it next to our existing function.
Okay.
What should we call it? If we call our tests dot tests.ps1, Pester will pick them up automatically. I think it would be a good idea if you named this convert to km.tests.ps1. I think all of you should create a file in the private directory convert to km.tests.ps1. Brand new, empty file, looking just like this one.
And that's how you start.
So we've got an empty file. So the first thing...
Yes.
I know. So it's hard. Because the first thing to do with your test is the describe block. But actually, we're going to start with a before all block, aren't we?
But where does the before all live?
In the file. Anywhere in the file, in fact. Okay. So we have... yeah, if I do, because you can then tell me what to write. And I'm much better that way around. So I can do this. Let's see. Oh, you don't know that you're a Pester file. Okay.
I think you need to do a describe first.
Should we do describe first? We'll do the describe. There we go.
Because before all lives in...
Inside a describe.
Yep. So whenever you start making a test, describe is the parent.
Excellent. So I'm going to write describe. And then...
Script block.
A script block. Okay. So we'll have a script block.
And now we tell Pester, do we need to do something? What are we going to test? Are we going to maybe load a file? Load a function?
AI knows. Yeah? Like AI knows. I have never written this in this session on this thing. Never, right? AI knows. It's pretty freaky sometimes when it does stuff like that. So we're going to start with a before all block.
Yep.
Okay. Guess when the before all block will run? Before everything.
Yep.
Guess when a before each block would run? Before each thing.
Yep.
Okay. So what are we going to do in our before all of our tests?
Well, this test is related to a function. So we need to load that function. How do we normally load a function within PowerShell into memory? You dot source it. Is there anybody who here does not know what dot sourcing means? Please raise your hand. One. Okay. Dot sourcing is basically loading it into memory so that you can use it as a built-in commandlet. So what it's quite common is that you do dot and then the location to the PS1 file, and then it simply loads the function. So it has to be a function, not a script. And then it loads it into memory, and you can just use it where in whatever path you are, you can just use a commandlet name.
So before all, there is a dot and a space. Run this script and load it into my session. And then, like you said, we've got PS command path I'm running right now, and a replace dot tests and a dot PS1.
This is why you name your test similar to the name of the function file, because they are related. So in this way, it just goes like, oh, I know, I'm related to that one. I'll load that function. That's it. Now we can actually start interacting with the function within the test.
What do we write to write a test?
In order to do a test, you need another keyword.
Okay. What is it?
It is, yeah, exactly. What is it?
What is it?
It is the test.
Oh, it.
The keyword is it.
The test. So if I type it, oops, let's not put it there though. Let's put it here. It is our test. And it's another script block?
Yep.
So should we give it a name?
You have to give it a name.
Oh, okay. I have to give it a name.
If you don't give it a name, it starts bugging out.
A good name would be test 1, right?
Of course. And test 2
and test 3 and test 4, yeah? Would to be something better, perhaps?
Perhaps something like git commit messages, what it actually does, what you're expecting it to do.
Tested a thing. Testing a thing?
I've tested it. It's fixed.
Okay.
Okay. So here you simply say what you think this specific test should do. So in our case, we're going to simply convert 1 mile to whatever amount of kilometers we expect it to be.
So we've got our it block. We've given it a name, a title. The title's really important because that is what's going to come out in your results.
Yeah.
So that's going to kind of come out in your CI/CD runner. So you need to make sure that it makes sense. Okay. So we're going to say 1 mile should be 1 kilometer. And how do we write a test?
Well, this is basically it. But the important things here again are you do the convert mile. So you run the function as you would normally do. And then you do the pipe. And then you use the assertion keyword called should.
Should.
So that's basically what I said up front is Pester, you test your assumption, or officially it's called assertion, but I'm horribly bad at those words, so I try and find words I can relate to.
Assumption makes sense.
So I assume that if I run convert to KM with 1 mile, the outcome should
B.
space -b, and then the expected output. If I do this, I should get this.
So it's kind of like English, yeah? I expect that the thing on the left-hand side of the pipe, should, that bit word is vital, and then should be, shouldn't be, not be, should be exactly, should be bigger, should be a type, whatever we're expecting. Okay? This is how your testing is going to work. What I'm getting with my PowerShell, my convert to KM mile 1, and what I believe it should be, because I know what the answer should be, because I've set it up. Yeah, you know that 1 mile in our code should come out as 1.60934. So because we know that, we can put this into our test.
What now? We have all this code written. Are we done?
Oh, I think we're pretty much done, aren't we?
I think,
Hang on a minute,
this
let me
should
test.
be a test.
This should be a test.
How can we now see if how do we run the test? How we do this?
First, number one, most important thing that you will get wrong as often as I do. Control S. Save the file.
Yes.
If you don't save the file, the test doesn't run. And you can spend a long time looking at why your test didn't run if your file is not saved. So our file is saved. We're going to open up our terminal. And it's amazing because I can just do this, can't I? Oops, invoke Pester. I'll just run that.
Yeah. Give it a shot. Let's not try it like that. Why did it fail?
Why did it fail?
That's a good one.
I know why it failed, I think.
What'd you do? Oh. Yeah.
Yeah, no. I knew that when we started. Sometimes I make mistakes that are deliberate. Okay? There is no name for our describe. So each one of these blocks, it is important that they have a name or a title. It's important so that you have them coming out in the output, but it's important because otherwise they don't run.
Yep.
So this should be, what, some sort of test? This is our grouping for this command. So this is our convert to KM tests, or tests. There we go.
Yep. So basically, this is the main name of what are we going to test. And in this set of tests, we're starting off testing this function. So we have to provide the name.
It's really important that you understand that we can show you when stuff goes wrong so that you will see it. Because when you get home, you will see that sort of thing. So the message was there was no test block provided. You should be thinking, hang on a minute, maybe I don't have my title. So now, invoke Pester. Every .test file in this directory recursively, Pester is going to look, do some discovery. I'm going to look through these files. I'm going to see if I can find anything that looks like Pester. Great. I found something that looked like Pester in one file, and in that file, I found one test. Yep. And that took 188 milliseconds. So you're getting this output, understanding how our test is coming through. Then it says, I'm running the tests. It gives us the file, and it's green. Great.
One thing I personally prefer, especially once I get started, is I made the if block, and I don't see that information anywhere. Can I get that information?
Okay.
I want to see exactly which test does what, or exactly which test fails or succeeds.
So let's have a look at a command like we would do with anything. We'll look and see what parameters we have. Okay, so we've got all of these parameters. Maybe output might work for us. Yeah, so let's try an output.
Sounds logical.
And if I do control space, I'm getting all of the available options for this parameter. Normal PowerShell stuff. Should we go for detailed? Want some detailed?
Detailed diagnostic. Yeah, detailed should be. There we go. This is what I personally prefer.
Okay.
So,
how about if I'm running on a runner or a CD agent or something?
yeah, it's similar.
Well, do I really want to have all of this output? If I'm running these tests at 3 o'clock in the morning, should I waste these CPU cycles?
Just do minimal. Or none.
We can do none. And a pass through.
There we go.
Oh, come on. Did that test really run? $A? Oh, yeah.
It did.
The test runs. So Pester gives you the opportunity to have just the summary, which is where we started by default. All the detailed view that Robert wants, like I want to see all of these describes and context and all of this stuff. Or nothing at all, because we don't want to waste CPU cycles. So you can pick and choose which one you want. But let's go back to our detailed.
We've made our first test. This is as simple as it can be. But the essential thing is, it's sort of like grammar. You need to understand some basic rules about what it needs to actually run, how it interacts with the function, etc.
How many people have just written a Pester test in here? Result.
That's a lot more than...
Let's go get a beer. We've done. That's it.
Thank you.
Yeah, thank you.
That's
awesome.
That's the first steps. So, but what if we now want to test
So see, the problem is, if I have to keep on writing the same test, do I have to keep typing it and the name and all of those things?
Well, you could.
Okay.
It actually works like that. So if I want to say, I now want to test, like, what if I enter 5 miles? What if I enter 10 miles? Does it still go? I can keep writing the same structure of, or is it touchscreen? Good. Yeah. I can use the same if block all over again and again and again and again.
I got you. Hang on. Let me just do this. So I can just do Control, Alt, and down arrow. There we go. Right. So 2 miles should be. Hang on a minute.
That's a good question.
3. Is there an easy way of doing this?
Yeah.
Yeah. Okay. Can I not just do like in PowerShell? If you're looping through, what do you use?
Anybody know?
For each. Can I use a for each?
Yeah.
Excellent. Awesome. So let's try this. So we're going to do dash. I should have just explored. Even though this is just a single word, I can still get the IntelliSense. So I've got for each. Okay, what does that take?
That takes a hash table.
A hash table. Okay, so we'll have a hash table.
And now you do all scenarios that you want to have looped through so you can test them.
What I'm going to do is go and copy it because it's
otherwise
better.
We have to calculate the...
Yeah, I can't remember how to calculate these. There we go. So our for each is a loop. It could be just an array of strings, numbers, whatever. But here we've got two things, yeah? We've got what we're going to put in and we're going to be what we expect out. So the values we know, solid values that we know and understand, we're going to put into our code. And solid values that we know are going to come out of our code. So that whatever we write in this convert to KM, we know we should put in 1 and it should be 1.60934 and all the rest of the things. And anything else that you're writing for your PowerShell, you should follow this same logic. So let's paste into our hash table some objects.
Now, and of course, since we're doing the official conversion, you could, as a test, change the function to be 1 to 1.5 or something easier, but this, we had it as a test. But how does it now know how I can use the for each loop? Normally you do like $_ PS item.
Yeah. So if you look at what we've got here, it's PowerShell. Yeah. So because here our objects are all mile equals, mile equals, mile equals. Yeah. And everything here is expected. So we're setting up our object in a very specific way with a naming convention. And then in our assertion and our test, in our test, we've now changed it so that we're going, instead of mile 1, we're choosing the variable $mile. Because this matches this. Okay? Cool.
So similar like splatting, if you have a command and you don't want to input all the parameters, you splat the parameters. Only in this, it doesn't make it into parameters, it makes it into a variable you can reuse. So whatever you defined in your hash table, you can reuse in your assertion. But now we have something that might be a different problem. It says 1 mile should be 1.60934 kilometers, but we're not just testing that, are we?
Oh, okay. So in our name block, in our title, we can refer to these same values, but they're processed in a different way. So here we're going to say, what do you call these? I call them greater than.
Yeah, I call greater than, lesser than, I have no clue.
Well, whatever they are. And we'll put a underscore. So that is the this in our loop. That is the PS item. That is the $_, but only in a title. But this is an object. So we're going to say $mile because it's PowerShell. So it's the same way of traversing the object that you expect. And we're going to say here, these two things.
Wait, before you finish, what do you guys think we should enter here? What's the named property we're actually looking for? Does anybody have a clue? Expected. There we go.
I expect it's the expected. Okay, how do we run this file? First, most important thing we do, save the file. Thank you very much. I guarantee there is going to be one time we do this and I do not save the file. And it'll be all of their fault for not reminding me. Okay, so do you want to have it detailed so you can see everything?
Yeah, actually, I do.
Okay.
Ooh, I saw that one coming.
Didn't see that coming.
I saw it had a squiggle.
Have I missed a squiggle?
Yeah, because I see that one. It's good.
Should be right.
Hmm?
Right.
Where? Oh yeah, the for each should be. Oh jeez. Yeah. That's what I screw up.
Do you see how I'm literally? I am like a computer. I'm typing what I'm told to type and not actually processing whether it's the correct thing. Sorry,
that's
buddy.
why I'm reading from a glaring screen.
I've led you down a path, and I apologise. Thank you.
My bad.
Feel free to shout out because don't forget, I learnt about this morning, and I'm doing the best I can. So, I did say thank you. Okay. So now we're going to run some tests. There we go.
There we go.
And this time, if you look, you can see that describing the name of the test, and then it's got each of those values. It's cool, right? Who has now just written 4 tests? Yeah. People have. Some people have.
Yep.
Less than wrote 1, you notice, but that's cool. We'll keep going.
It's good enough.
Yeah. And down at the bottom, we've got some results. Passed 4, failed 0, skipped none, and really not sure 0, and not run. We'll look at those later.
So we have one function properly tested.
Well,
What about doing one of the other functions? Perhaps the convert to difficulty number. If you can look at the code, maybe you can start writing a test for this function. It's sort of like the follow along is now like an assignment.
assignment, yeah. We're
Try and write your own.
Yeah. Can you
Simple
write
test.
your own Pester test to test this function? Okay. So first thing you're going to want to do is create a file. The file must be named something.tests.ps1. My preference would be convert to difficulty number. Yeah. Inside there, you're going to start with the first thing you start your Pester tests with, which is the describe block. And as we've learnt, every block in our Pester must have a name. Okay, so I'm not telling you how to write this test. I'm giving you the run through of what we've just done. Once we've got our describe block, we then had the thing that runs before every test, which is, thank you. We have the thing which runs before all of the tests, which is a block that is called before all. Now you need to load the function because it's a private function. So that's exactly the same as we did for convert to KM.
And the most important thing here is that the reason why we ask to try and do, because once you start working with Pester, at first you're going to fail and you're going to get weird results. And we can show you exactly, it's perfect like this. And if you do it like this, it works all the time. But it's like learning PowerShell. It's like you have to start doing things. And it's going to get more advanced later on.
Yeah.
But you need to understand and grasp the basics before we can start doing more advanced things.
Once we've got this one out of the way and you've written this, we're going to start to speed up a bit. Okay?
Yep.
And then you're going to need to just keep going. So look, if you look at the top of that file, it looks exactly the same as the other one. Okay. Anybody got an idea about writing a test for this one? Oh, we're all very quiet, Robert. We don't want to talk about it at all. We're all very shy.
We're scary, apparently.
Okay, that's okay. Should we just describe what we've got?
Yep.
We've got here.
We do the same thing. We have 3 possible options: easy, medium, hard in the conversion, and we know what it should convert to. So we could write a simple test for each and every one of them, but we just learned about the for each option. So we're going to immediately try all 3 of them.
Sorry, what I was going to say was quite often I'll do that when I'm working on it. Yeah. So
to have the function right next to it.
I've got the function here next to it, and then I have the test on this side. Makes it a bit squashy here, but just so you can see, that's because normally we'd be working not quite so zoomed in.
In a different, yeah. Okay, so we now should be able to make one simple test to test if the values match.
Okay.
But what if we provide invalid input, or if something doesn't go as expected?
That's a good point. You don't always want to just test the things that are going to go right, because we have those squishy pink balloons full of red stuff, the human beings. And what human beings do, they're amazing at it, at putting the wrong things in. So we want to make sure when we're writing good code that we handle what happens when you put the wrong thing in. Yeah? So in this scenario, you've written a test that says it fails for null.
Yep. Because we don't have proper input validation in the function at the moment. So I could simply input null. But what should happen is it should throw, or it should just die on me.
There should be an error.
Yep. How do you test that?
When you need to have an error, when you need to test if you are correctly getting an error from your function, you're still doing exactly the same thing. What I have got, pipe, should a thing. And in this place, it's going to be should throw. That means I expect you to fail with a terminating error. But on the other side, smart eyes will have noticed that we've passed in a script block. Okay? The one above on line 16 is just running the command, taking the output from the command, passing it to the validation. Here, we are running the command within a script block, and if the command throws an error, it's going to correctly pass that test.
What happens if I don't add the script block?
Then you're going to get an error coming out in your test results.
Or, in some cases, the function's going to ask you the mandatory parameters, and it's going to actually want interaction. So that's what you don't want.
Best way to find out what happens, have a look.
Yep. So here you can see that we already have the conversion, all the successful passing tests, but the failed one.
I've taken the script block out here.
Yeah.
Yeah. See, look, it's thrown an error for us. So let's put our thanks VS Code for being helpful. Do you see?
No.
I have a passing test because my command has thrown an error, as expected. That's what I wanted to do. But my test is green, and I have no output because I've put it inside the curly braces.
And in this case, you can do the same thing as what we did with the positive tests, and you can also make a for each for invalid options of input. So it goes both ways, and that's what you want to start doing in your real-life code in production. You want to make sure that if you do invalid inputs or something dies on you, or what happens if you talk to an API and you get a server error, you normally, in your code, you will do a try-catch block or something of error handling. You can now test what happens if it goes as expected. And that's a very important thing because you can test ideal situations as long as you can imagine, but it's not going to work like that.
And this is the point when you would build in these tests when your users are starting to use your function and it's not doing what you expect. And they're coming back saying, oh, it's failing like this. You're like, oh, right, yeah, okay. Yeah, we're going to make sure that it works as you expected. Do you want to talk about this one? Or should we just run it and let them go?
No, I think we'll skip to the next one.
We'll skip to the next one.
Yeah.
So we'll just show that we have still got passing tests, one for each of the commands. 11 tests. We're testing our conversion and we're testing our convert difficult numbers.
Okay. So we have some of the private functions tested and it's all looking perfect.
Yep.
How about looking at one of the public functions now, like the main one that the end users are going to use, the get random track. Was it actually the right thing to do, starting with the private functions? It looks all perfect now.
Yeah, everything's green, right?
Green
We're all
is good.
Green is good. Do the users use the private functions?
They can't. They have no clue there are private functions, maybe.
Bartek could. Yeah. But
Even if we don't want to, he can.
yeah, the general people are not going to know about a private function, right? So probably better we led you down a bit of a path because you were like, yay, private functions, because they're easy and they're small. And that's what you'll think. Don't waste your time there because your users are going to do other stuff. That's where you should start. So how do we test a module? Do I have to go and import every file as I go through?
Nope. Luckily, we don't need to. So once you start testing public functions, they can have references to other functions. So instead of what we had before, the describe, the before all dot source the function, we need to actually load the module or import the module because it's going to reference other functions most probably. So in order to do that, we're first going to make a new file again.
Cool.
Same name next to the function that we're going to test. But instead of dot sourcing the file, we're now going to import the module. And we can't do it like the normal import module name. We need to actually refer to the PSM1 file. So everything that's in there gets loaded. Yeah. And we do a dash force to make sure that if we keep testing it, that we get the latest one.
So testing private functions, import the function file, then do your tests. So you got them in your session. Testing public functions, import the module by referring to the PSM1 script file in your directory. So this is we're going from PS script root and we're finding our PSM1. Make sense? Again, it's before all. We're going to do that. Quite often, if you're doing this in some automated fashion, you probably want to make sure that everything is cleared out and you're in a brand new clean session. Okay, this is really cool. But what happens, like, if I look in the code for get random track, what it does is it...
Wait,
no,
that's the one.
Let's not look at this. We look in the code for get random track.
Yep.
There we go. That's much better. If I look in here, then what I've got is this invoke rest method. So if I run this command in my test, does that mean I've got to have the API running so I can connect to it?
It's going to talk to a live system, isn't it? But we don't want that, especially if we're going to do specific actions. If we do a get, it might not be that bad. But what if we do a post or delete or
patch,
whatever? Or we have another function that we use like remove mailbox, or we don't want to actually run that specific bit of code to a live system.
I mean, it'll test that it works.
Yeah.
Because the phone will light up if you remove the CEO's mailbox, yeah? Probably not a good test.
You want to test that one?
No, it's okay. Thanks.
Okay. So we have a different concept, which is called mock. And that's a very important concept. So basically what we've done up to now is like the easy syntax for like small things that we need to test. But mock is going to be, I think, one of the most important tools within the Pester framework. Instead of talking to that live system, we're going to say, if we were going to run function X, so in this case, invoke rest method, instead, we'll do this. And this can be throw, or just give no output, or give us a specific value back which we can test against.
So you've got 3 options.
Yep.
There's more, but there's 3 options. I would like to make sure that my code correctly calls this external function. Okay. Imagine you've got a 2,000 line function. Don't write 2,000 line functions, but imagine you do. You're taking over somebody else's code. I know, we're trying to fix it. And your code path goes like this. And you want to make sure that if you put this parameter in and it's on a Wednesday and you're on the prod system, it goes down this code path. You want to make sure that it calls this function, but we don't want to run it. So you can return nothing. Or you want to make sure that when I call this API with Bartek, I get back an email address of bartek@iamtheamazing.com, because that's his email address. Right? And in which case you can specify that there is a particular result set that you're going to put in, and that's going to be your should coming out. Or you might just want to throw, because you know how to test for a throw. So if I successfully reach this code path with these particular parameter values, great, excellent. Now we can test for a throw.
So in this case, we're going to, in our function, we're going to run invoke REST method. And it might seem weird at first that we mock initially on line 24, that we mock the invoke REST method with a throw. That's basically to protect ourselves. That if it gets run, that it doesn't touch a live system. Because what we're going to do just now is define, but what if we call invoke REST method to this endpoint or this URI? Then I do want to get a result. But in case something in my code messes up and it still for some reason calls invoke REST method, I don't talk to a live system.
And sorry, go on. I was going to say, and you write a mock like this. Okay. So again, another one single keyword, not verb noun. We start with mock. You have the command name that you are going to mock. Invoke REST method. And then you say mock with. So this is the thing we want to put in. And in this example on line 24, we're going to throw so that we don't shoot ourselves in the foot, delete the CEO's mailbox and get sacked, right? Good idea. Yeah. We want to make sure we save ourselves. But we've got this extra module name runner here. So another parameter afterwards that says module name runner. What does that do?
That's basically because of a scoping issue. Otherwise, it doesn't know. It's going to say, oh, if you do it in your current session, but we're also loading the module. So it needs to know that it's in the right scope, that it knows which invoke REST method to actually mock. That's going to be very important that you add that parameter, because otherwise it's still going to run your code. So you definitely do not want to forget that one.
You definitely don't. So if you have saved yourself from shooting yourself in the foot, like Robert said, we want to test what happens when I put something in. How do I get that out? And that will work like this for our line 27. Still have our mock and our command name up front. Still have the module name on the back. This is our module that we're running, yeah, our runner. And then inside, we've got these two things. Still got a mock with, but we've got a parameter filter.
Yep. Parameter filter is basically, okay, if invoke REST method gets called, so within the function that you're testing, if it gets called and it gets called with a specific parameter or value, what should it do? So in the most common cases with APIs is if I call endpoint A, I should get result 1. If I call endpoint B, I should get result 2. And that's exactly what we're doing here. We have, as shown at the start, the API has 2 endpoints. the tracks for the random tracks and the ratings for the rating for each track. And the getRandomTrack combines that information and makes one object which has both the track and the rating info in it. So because our function is calling two endpoints, we want to make sure that if we test it, we get reproducible or testable information. Because similar what you might have with getDate. If you run getDate, every time you run it, it's gonna be different as before because it's a couple milliseconds later. But this way, if I mock getDate with a fixed moment in time, and it doesn't have to be like now, or it can be January 1st, 2025, something like that. But it's a testable result.
Hey, so if my company started in 1999, I could set a date of 1998 and say if you run invoke method with a date before this specified date that I've set, 1998, then we should get no results back.
Yep.
Just to make sure that my code is handling that. So this particular one is going to mock our tracks. Yeah, we've got two routes. This is mocking our tracks, and it says I'm going to mock with this particular output. It's a PS custom object. So we need to match the same type as the thing that you are doing. This is going to be the things that are hard. Okay? This is where you need to understand your code, what's going on. So you probably need to have hit the API, pulled back some results, like literally like that, and gone, okay, actually, this is what it looks like. Turn that into a PS custom object for one thing, because that's what invoke REST method is going to bring us back. Now we have something that we know about.
And similarly for the ratings, it's the exact same thing. And I had a question yesterday from somebody at the conference saying like, well, how do I know what it's going to look like in real life? Or, well, most of the times you'll be able to just test something first, or it's documented. But I had
there'll be a Swagger that you can Swagger page you can go and play with. Yeah,
I had a session 2 years ago about talking with APIs through PowerShell as well, the Microsoft 365, and you show using dev tools or something like Fiddler what body you post or what you get back, and then if you've done it once, you simply have that object and you can reuse it. So you can't always get easy information of a live system that you don't control, but if you can do it once and capture that object, and like I said, how to do that, that's a different presentation altogether. But once you have the information, this is what I expect the output to be like, then you can just rebuild it. And then if this time we have under line 29 and down the object, we've taken an actual file that's in the tracks listing, but you can make something up, but you just need to know what it should look like because it's not actually getting the data.
He's made it up.
Yeah.
The track ID he's made up.
Oh, it is.
Yeah, because I wish I went and tried to find it. But here's the thing. These mocks are now scoped within the block of Pester that they're in. So in this case, we're in an it. It's quite possible to put these into a describe. It's quite possible to put these into a context, which we haven't mentioned yet, but we shall. So this it block says, when you run whatever code, if you hit invoke REST method and you got nothing, throw. If you hit invoke REST method and the parameter has tracks, then return this, please. If you hit invoke REST method and the path is like ratings, return this, please. And then we go, right, now we're going to do our test. And our test, we can do some PowerShell here.
Yep.
Right? So Here we're actually testing a number of things. We're going to run get random track once, capture the result, and then look, we've got 1, 2, 3, 4, 5, 6 6 tests within this one it block. What happens if all of them fail?
It fails.
Okay, good. If all of them fail, the test will fail. So what happens if all of them pass?
They pass.
Excellent. What happens if 5 of them pass and 1 of them fail?
You fail.
You fail.
Because it's one it block at the moment. So it's one test, and that I'm testing multiple things within that one test. It doesn't matter. It's one test, and that test is either everything successful, or even if there's one fail, it's a failed test.
Oh, but surely what I could do is I could say actual pipe should be and build the custom object, right? I mean, I could.
Yeah. But do you want it?
Do you want to? It's harder. And like, honestly, it's harder. Much better to do it this way.
Yep.
That's a tip that we are giving you. Don't think, oh, I'm getting a custom object. I'm going to test for a custom object that has all of these values. Much easier. Test all of these things, knowing that it must always be everything passes. If
On
only
a side-
5...
Wait,
Go.
quick. On a side note, and this is unfortunate that Jakob is not there. There is something new coming in version 6 that you can actually test an object against something. That is something Jakob could explain a lot better, and it's not.
Yeah.
It's still in alpha, so
It's not fully baked, is it? Yeah.
as for now, this is the way to go, and that's the advised way for now.
Okay, let's speed up a bit. So now
okay.
we've done an it, we've done a provided track when there's just one. Now we're going to do some different values to make sure they come back correctly. And we're going to talk about random. You like this, don't you? This makes you chuckle. Okay.
This didn't make me chuckle. Okay.
So go on, you start.
Okay, so the function is get a random track. But is it really random? How do you know for sure that it's random? Well, in our code, in our function, we use the getRandom function, which is not one we made. It's built in. But how can we test?
So we could mock it and we could make... Oh, hang on a minute.
That's a pain. We shouldn't have to.
It's random, isn't it? Because... Well, we could do the other thing, yeah? So we can make sure that if it runs, we do a throw and we can test. So we know we've hit a random, yeah? That's good enough, right?
But that's not really ideal because we don't want it to throw. We just want to make sure it
not
gets...
really the actual test, is it?
Yeah.
So it's really interesting challenge here is that if you imagine that when we're running get random, we want to make sure that it calls. So there's a way of testing. Is that what we do? Yeah, should invoke.
Yeah.
Okay. So we've got this should invoke here. And that says, when I run this particular test, you should have hit get random exactly once.
Yep.
Yeah. And this can be any of those. Okay, the whole bundle of stuff you can add in there, but we want to have exactly.
And why is it exactly? It's because in the parameter filter, we say the input object is just one. We query just one random track, so it should get just one hit of get random. So if we input more, we can get more hits.
So here's a way that we're testing that our code is correctly hitting this function, and we're not caring really what it returns, but we're just making sure it gets hit. We're making sure that the API returns the right thing. We're just not testing the randomness. We're assuming that get random is going to do what it should do. just like we assume that get command is going to return a command. We're not testing Microsoft's code for that, but we are testing that we are calling that code correctly.
Yep.
But if you've got multiple tracks,
how do you test the randomness?
How do you test the randomness? So it's really tricky. And we were talking about this last night. Because the thing that you're testing is that when we get it back, we're getting a random amount of results. But also maybe you're looking at testing a whole array. Right? So if we need to test an array from 0 to 10, we want to make sure that we're getting all of these answers. We want to get all of the answers. Our code shouldn't just start at 1. Make sure we're getting everything. When we're testing randomly, well, what we could do is we could define 1 to 9. If we run get random 50 times, we should hit each of 1 to 9 5 times or more. Yeah. If we don't hit 0 at all, something's wrong. So use that logic, and we will say it gets a random track whenever there are multiple tracks. We save ourselves with our throw. And then we say, here are some example tracks. We've got a 1, 1, 2, 3, 1, 2, 4, 1, 2, 5. We've got 3 random tracks. Okay, and then we're going to say, we're going to mock our tracks. URI, cool. We're going to create some ratings for the same. We're going to mock our ratings API call. Now, if we run 20 times for a length of 9, and we sort uniquely, then we should be getting 3 results. Because we've passed in 3 things to our get random. We've run through it way more than 3 times, 20 times. If we only got 2 responses, 2 unique responses, we've done something wrong in our code.
One of the tracks will not be returned, and we should always get all of the tracks, especially because we run it 20 times. It should hit each and every track at least once.
This was the thing that blew your mind last night. It was like,
you have to think a little different. And once you get it, it's like, oh, okay. But thanks to Rob and Jakob before me, just like, oh, that's normal. But for me, it was like, wait, oh, now I get it. So you're going to have that a lot more with mocking. You have to approach things a little different than you might be used to. So especially more advanced mocks, you're going to run into syntax things or, oh, how can I actually test this? Or what do I need to mock? You're going to grow into that.
Right.
Yeah.
I'm gonna say this. Right now, you've been sat there for 70 minutes and you're like, whoa, okay? So anybody who's got a computer who is sat doing some code, write a test for throwing a command, right? Something that's going to successfully pass a test when a command is thrown. Anybody can go to the loo, grab a drink. Maybe there'll be a biscuit somewhere. I have no idea. It's 11:15. We will start talking again at 25?
25.
Right.
Yeah.
We will start talking again at 11:25.
Yeah.
Okay. Stay in here and write, go for a wee, do anything you want. We'll be back at 25. And then we're going to do some things about testing with files. We're going to look at the Pester configuration and we're going to talk about CI/CD. Okay? Yeah, in 25 minutes. Your brain is going to explode. If we can make Bartek's brain explode,
That would be amazing.
Yes. That would be messy. Okay, we're going to
I'm
start
not
talking
cleaning it
again
up.
at
I'll be
25.
behind this one.
All right, we're not quite starting yet, but we're
Yep.
we're a couple minutes for people to come in. How you all doing? Okay? Nodding heads, shaking heads. Yeah?
People asleep.
Fall asleep. Learning things that you expected. Yes? Nodding heads. Good. Useful? Stuff you can take home? Yeah? Good. A double thumbs up.
Double thumbs up.
Can't do
That's
better
what we're
than
going
that.
for.
Yeah. So what we will also do is we will transfer. You've seen we've got a sneaky little repo that has all the notes and the code in so that Rob doesn't mess up the typing. So we will make sure that that gets moved into the PSConfEU repository. Shall we say today?
I had a question from somebody as well, going like, "Oh, can you show the code out, or do we have the code?" As soon as possible.
Yeah.
Because like we had we set up, me and Jakob set things up. We had to change things around. Well, we have the code. We will share it. We will let you know where it is.
Yep. So it will definitely be available on the PSConfEU
definitely.
repository, so you can get it from there. Okay, and then you can take it home, you can run it. It's completely independent. We will probably do 2 branches.
Yeah, that's what I'm thinking.
Yeah.
So you can have the clean startup that like we had before, and then you can have like, okay, how is it fully tested and everything? So you can refer to that if you want to play around with it.
That's what we think, but we've had like literally only a few hours to think about this.
Something like that.
Something like that.
Yep.
Okay, so people are still going to keep coming in the next few seconds, and that's okay. We're just going to keep on going so that your minds are completely melted by the time you get to lunch, which is at what, 3 o'clock, isn't it? Lunch. We go till 3.
3:40.
Look at these faces. Whoa, no!
Wait, what?
No, we will get you out in plenty of time for lunch.
Okay, so
let's recap.
yeah,
We've got a module that is doing some things about getting tracks for runners. We wanted to write some tests for it. We started off by writing tests for our private functions. We imported the file because it's a private function. We ran some tests with an it. That's the test. We looped through with our for each, and we tested that what was being returned from the function pipe should be what we're expecting. And then we've done the same thing for our public functions, except that this time we decided, we need to import the module up front, and we're going to import the module from the file base, not from PS repository. We're going to do it from the file that we're testing, because then as you update your code, you can rerun your test. Everything's just running here nice and locally. And then we've talked about how we can mock our commands when we are calling external functions. We've talked how to mock for a throw, so we don't shoot ourselves in the foot and delete the CEO's inbox. And we've talked about how we can mock with just nothing, so we can ensure that our code hits this external function. And we've showed how we can mock for a certain value, even regex value in our parameter, and return a particular object. And we can mock multiple functions or the same function multiple times within the scope of our describe, our context, or our it block. We've made sure that all works. So now what do we have to do to make sure that we've got the file correctly? We have to make sure we've saved it. We have saved it. Now I can run invoke Pester. We can run invoke Pester. It's going to run all of the .tests files that we have recursively from wherever we're running it. And if I just run it like that, it's going to tell me that I've run these. We've run these tests that are in this file. I've run 15 tests, but actually it's only showing me the results from 3. 2 of them have passed, 1 of them has failed.
Yes, but that's weird. Why does it fail? We thought it would be best to do the private functions first because, well, that's easy to do, but then we said, well, the end users are going to talk to the public functions anyway. And, well, for example, the convert to KM function, we know that's right.
It's definitely right. We tested it.
How could something still fail? Well, if we actually look at running some code, okay, if I can just try.
You can go. I was just going to say that the thing that's failed is we expected it to be called once, and it was called 0 times.
Yeah.
So,
but one thing we noticed that in get random track
with a length of 9.
And I think, give me 1 second.
Make sure you get the right code.
Yeah.
And a difficulty of easy.
But instead of, this is, if I run this now, what is the length standard? Does anybody know which length I'm referring to at the moment? Anyone? It's kilometers. That's the default.
Right?
It requires. It doesn't have anything with a length of 9 kilometers with difficulty easy. If I use... What? Wait. Oh, unit. That was it. I was about to say.
Good work.
Thank you.
Thank you.
It's... Wait a minute. I'm doing something wrong.
Where's your code?
Here, this one. I got it. Length 9, difficulty. Okay. The whole thing is, I can't show it properly now, but there's a bug in our getRandomTrack function, actually. It's not processing the information correctly. Even though we've tested the convert to KM.
It's definitely not working correctly. We're not getting... Where's our getRandomTrack code?
Oh, crap. We don't have the API. The API, or is it still running? Oh, it is. Okay. That's all fine. The main thing is I can't get it to reproduce at the moment, but we have a bug currently in our getRandomTrack code. And it's not processing the length correctly. So if we look at our function, you can see that if we can get it to work.
Okay,
Yeah.
so we do have everything. Here is our function. Yep.
Okay. Who can figure out that if we want to set miles, why is it not working properly? If you can scroll down a little. Yeah, just about there. So on line 13, we're actually calling the tracks. We're getting the tracks. We're converting it. Why is it? I set miles as well. The ordering is wrong.
The ordering is wrong.
What ordering is wrong? Yeah, I pass the information in to the parameters for the URI, and then later I set it. So there's a bug in my code, and even though I've tested the convert to KM, it doesn't even process properly. So the function might do anything. The private function might do what you expect it to do, but I'm not calling it correctly. So I'm not using it. So in the end, my user experience is still going to be buggy. So we need to change the bug in code.
That's better.
Yeah.
Now we're getting the parameter.
Yeah. But it's still not...
But we still have the bug, but yeah.
Yeah. And so we need to fix the bug in our code in order for things to actually start working as expected.
So the important thing to remember here is that what we did is we tested our private function. Our private function did exactly what we expected. And then we assumed, because it did exactly what it expected, that our public function would be working correctly for that length. Turns out, because we've probably copy and pasted wrong, haven't we?
Yeah.
We've got the ordering wrong, and when we're defining what our length is, that the convert to kilometers function worked completely brilliantly. Except we'd already used the length that we'd given. When you're writing your functions and you're testing your private functions, they can work absolutely correctly, and your public functions can go wrong.
Your implementation is incorrect. So you're best off even though it might seem quicker, easier, better to start working on the private functions. That's how I started going, oh, this is a logical thing. This is easy and smart, and do the test there. You're better off starting immediately going to the public functions. Get user experience in. So if I move this, wait, there we go. Move this to here. Control S. Then
Save the file.
Yep.
Yeah, I know.
Save. Then I think it was this. Oh no, that's not.
Oh no.
No.
Hey, stop trying.
Hey. Cancel.
Right. Control.
This one, right?
Single quote.
Yeah.
Yeah.
Okay. There we go.
Trying to hack my machine.
So I need to import the module again because I just made a change to the function.
If you up arrow, you probably got it. There we go.
And
Go on a force module import. Did you force it? No. Yeah, force. Just like we do in our Pester tests. Yep.
I don't know what broke there.
I
did it both, but let me see. I don't know what broke.
I don't know what broke either.
Trust us on us. I'll upload the working code. I don't know what broke in the last night. But if we run the test now, it should. Evoke.
Boom!
See,
Test pass.
did work.
Excellent. But also notice in the tests we've got actual 123, 124, 125.
Yep.
Because we had a write host in there. So your write host is still going to come out. Your warnings are still going to come out. Your errors are still going to come out in your test results.
So, time-wise,
we're rolling. Yep. So the other thing that you are absolutely 100% going to need to test are files. Biggest problem with files, just like you don't want to delete the CEO's mailbox, you don't want to test that you're creating files in something production-y or something that's going to cost money or any of those things. So how can we get around that? Can I mock a file? Can I just do like mock with blah, 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 blah? That would work?
It doesn't do it with mock. But
okay,
it has something else.
Tell me.
It's called a test drive. So basically, instead of creating a file or folder or accessing a file or folder which is under C scripts or under something else, you can have a file under a test drive. And Pester can access this. Let me see.
I'm trying to find the code.
The send track. Up.
Send track.
That's the one.
There we go. Right.
Okay. So in this sense, if you can see at line number.
Let me just fix it into the new one.
Yep.
Okay. Line number
Where'd it go? Line 11. Getting a temp file name. So I'm getting a temporary file with one of my private functions. And instead of getting a temporary file on my live system, it makes one under a test drive. And you can just say, that's where it is. I always know, because if I do temp file name, it's always going to be, it's somewhere similar to like get random. I never know which one it's going to be. But this time I can say, it's this file, it's located here. And now you can access it like it's an actual proper file. It can have content values, things like that.
Because it is an actual
Exactly.
file. Okay, this is an actual real life file. So if you've only got 40 gig space left on the hard drive on whatever you're running this in CI/CD, and you create a 50 gig file, ain't gonna work, right? So just because people forget that things test or just whatever, right? This is an actual real life file. The only way that you could test that you are correctly writing into an actual file is to actually write into an actual file. Yep. And that's what test drive does. It spins up at the start of our Pester, doesn't it?
Yep.
Whenever we load our Pester, we have this available to us. And then at the end of our Pester, thrown away. So no, you cannot run your invoke Pester and then go off and find the files and see what's inside them. But you can test for it. You could do a get content on a file. You can make sure you're creating files with the correct names. All these things that you do when you write your code all the time, that's what temp drive is for. Did I miss anything?
Nope. In that sense, what we're doing in this test for the send track, we know what the function does. You have to provide the GPX file, which we get through getRandomTrack, and it will then send it off using a temp file. It uses a function called getSecret and send email message, which are all external. We have them loaded in a fakes.ps1, which would be, for instance, if you have a third-party module that you're referencing.
Mm-hmm. You got no control over it.
Yeah, you have no control over it. You don't want to test them or make tests for them, but you want to influence how they act or react. So you mock them. So you say, oh, if I call getSecret, mock it with this, mail message, mock it with this. But the temp file name, I need to make an actual temporary file on my test drive, and then I can start comparing values and see if it's what I expect. So here I mock it with a test drive, like an actual PS drive. You can access it
because it is an actual PS drive.
I know. But you access it the same way. It just has a fixed name of test drive. Down. So I do the same thing again. I mock the behavior, or I do the behavior, and then it should call, similarly to what we did with getRandom, it should invoke that message, that command at once. And
also line 29.
Yep.
You've got your should.
Yep. It should match the content. And this is one of the parameters, like what Rob said earlier. Should has so many options on what you want it to actually check or match it with. And in this sense, we don't want to have just the content. We have multi-line information. So this is where you start checking what's supposed to be in that GPX file or whatever file you need to access. So it's not a tricky new thing. It's just we want to show you that's an option. It's available. Use it, because similarly to when mocking invoke REST method or web request or something, you would talk to live environments, and that's what's going to happen in your actual functions and modules.
So we've got one more thing to show you, and that's about the Pester configuration. Unless you had a question, Bartek.
Yeah, so the question that I would have is, like, so far you were showing us how to spot the bugs in code. How do you spot the bugs in your test?
Oh, super question. We don't have a lot of time for this, but the question is, how do I spot that my tests are working correctly? Because it's all very well and good. If I write a test that always passes, then I'm never going to know. How do I make sure that my tests correctly do it? You know how to do this. Your tests are always should this. If it's a should be, we got a should be in here somewhere?
I don't think in this one.
No. If you have a should be, then if you change the test to be should not be and run it again, it should fail. You take the not away, it should pass. Because you are putting things that you know about in and you're getting things that you know about out that you're testing against, you can control that, and it is very important to make sure that tests that are going to fail when they should fail. Because otherwise they can go on passing for 2 or 3 years and you don't even know. You can ask me about that story over a beer sometime.
Hit in before all. It looks like it's everything working fine, but it doesn't run this test.
That's a good one. I didn't know that. So Bartek says that if you were to put the it here.
No, before all, right? Or in?
It.
Oh, okay.
In the before all, it looks like it would run, but actually it hasn't.
And
you would be able to test that by a B and a B not are really easy because they're directly opposite. Anyway, we have little time. Go for it.
1 second. If you do the B or B not and you purposely fail it to see if it's going to say, this is what I actually got and this is what I expected to get. So that's your check mechanism for yourself. You go like 1 + 1 should be 2. And then it says, I expected 2 or I expected 3. And you can compare the values. And then, yeah, it's again up to you to go like, wait, what went wrong? What didn't go as expected?
Okay, so here we go. We could literally do it here. Look, let's just quickly do this. So we do a dash not. Is that right?
Should not be.
Should
not.
Not.
Yeah.
Dash be this.
Yep.
So now, if I run my Pester, boom, straight away.
Yeah. And you can see the at the bottom, expected this, but got the same value.
Yeah. I expected John's trail to be different from the actual value, but I got the same value. So there we go. Okay. Last thing before lunch.
Yep. Okay. So now we're running it locally, but our end state, our end goal is to actually start running this on CI/CD or anything like that, a runner that can test everything for us and that can give us all the information we need so that all our tests keep getting run over and over and the information we need.
Or inside sampler or some sort of, build process is already doing this. Yeah.
Now, we defined manually, to have the output to be detailed or this, or where our files are, or if we want some different settings, we could add more parameters. But there's something called a Pester configuration. And by defining that, that's an object which has all kinds of possible properties and subproperties. And let me see.
You just have 8 little.
Yeah. I was trying to check. So if I have Pester configuration, you can see that it's an object, and each of the things where we said before, the output, you can see the verbosity. We had it set to detailed or none, depending on what we wanted to have. And you can actually set that in here as well to say verbosity. You can see the output, and you set it to detailed. So if I then get it, so this is how I can define what kind of information Pester should give me, what it should look like. If you want to set up for CI/CD, you want to define all kinds of input, output, how I need to have it beforehand. So what the ideal thing would be is to make a simple test file, which has all the things you need it to do. So in this case, import the module. I make a configuration with all the settings I would like it to have. And then at the end, it's going to say, run Pester with this configuration. And if it has errors, just let me know. And what this gives you is nothing different from before, is it does invoke Pester, and it's going to tell me if things went fine.
I don't want to see all that output. Can we make verbosity none?
Yeah, sure. Oh wait, I have to do it here. Sorry. Come on. Verbosity. And then
there you go. See? This is how you can just quickly set that value. You set it every time. Maybe in your CI/CD process, you actually just set that verbosity to none, leave it as detailed for your developers, if you're working as a team, to be able to see all of the results. So you can see how you get all of this ability to configure your Pester environment. And there's a lot of stuff in there. There's a whole nother 90 minutes in there. Easy.
So now we have this file ready, and if we simply now want to implement CI/CD through either GitHub Actions or Azure DevOps or whatever system you're trying to use, in this example, we have how we would do it on GitHub Actions. You simply create the required .github folder with a workflows subfolder, and your YAML file is, let me see, that's go down. This is where you simply say, get all the code that we had. Of course, install Pester, because it doesn't always by default have Pester, or maybe not the version that you need it to be. And you simply call the PowerShell file that has all your invoke Pester with configuration. That's
Super
it.
Neat. Super neat. Do you want to show the test results XML file as well? So by default, Pester is going to go on.
No, I didn't hear you properly. Sorry.
I said, do you want to show the test results.xml file?
Yeah.
So by default, Pester enables you to output NUnit or JUnit XML file types, which means that all of your generic runners for CI/CD, your Azure DevOps, your GitHub Actions, your GitLab, all of those things, Octopus, are all going to be able to translate this into pretty pictures and graphs that show you how many tests have passed and failed. Or you can look in some XML if you want. But I hate XML. Okay.
That's basically how they parse it. And that's also what you define in the test file is what kind of output does it require? And that depends on the CI/CD platform, which format it needs. In this case, we use NUnit XML, and that shows within GitHub how it works. And I think we have an example on that one.
So what I can show you is, if we just go to this Fabric Tools and we look at an Actions We come down here to one of these, not the develop. Let's pick up a singular to plural. Okay, so this is an open source module. It's running using sampler. Here we have a Linux, a Windows PowerShell, and a PowerShell 7 set of tests that have all run. We publish our test results, and that means that we get that funky thing straight out. Looks pretty, yeah, nice and easy. You can always see. This was really neat because it'll show you the comparison between the last time you run the tests. So if you keep fixing tests, it will show it getting better. But this is literally run from that configuration of Pester object. We can't keep talking because these folk need to eat. And if we don't, if we stop, I know these things. If you stop PowerShell Conference folk from eating, then bad things happen.
But to summarize, this basically is all the goals we had set beforehand. Get an actual real-life module. Start making basic tests. Start figuring out the grammar, the syntax you need. Learn about mocking and why you would need this. And eventually combine everything into something you can push to CI/CD. And thank you, Rob, for helping me with this.
You're more than welcome.
But I think
thank you.
This should be more than enough info for now.
Thank you for Jacob. Yeah. Now, if you have questions, feel free to go and find. Oh, well, no, you can find us. Okay. Feel free to come and find us and you can ask us and we will do what we can. We will get this code up onto the PSConfEU repository. I hope you're all going to be able to use Pester. Please enjoy your lunch and come back this afternoon. Thank you.
Thank you. Thank you very much.